All right, let's move on here. We also might want to find the length of a triangle, a right triangle. That's not the hypotenuse, it's one of the legs. And so we can use a little bit of algebra. So say we wanted to find A, well then we could just subtract B from both sides, because the idea is we want to get A alone. So we could subtract B from both sides. These would cross out, and you would have A squared equals C squared subtract B squared. I kind of wanted to go alphabetical there, but then I thought, well, the subtraction will go second. So C squared subtract B squared. And so that would kind of be a formula. It's the hypotenuse squared minus the smaller side, the B, because hypotenuse is always the larger one. Now, what if you wanted to find B? Well, let's write down here A squared, the original one, plus B squared equals C squared. And I want to solve for B, so I'll minus A squared. Now these can cancel out. B squared, oh, it's doing this part again, which I don't know why, equals C squared minus A squared. Now I just like to write the C squared first. The C is a longer side, and then I subtracted the other one. So this is they're basically the same formulas. One starts with an A squared, but it goes hypotenuse minus the leg, and of course over here hypotenuse minus the leg. And I don't even know which one's labeled A and which one's labeled B. So let's just take a look here. Find the unknown leg. So in this case we're finding B. So for finding B, my formula will start with B, because that's what I need to find. And then I always think in my mind, okay, I'm going to go the bigger side minus the smaller, in which case that's the hypotenuse, which is C. So C squared minus the smaller one. Now B squared, I don't actually know because I don't know B, so I'm going to write B squared equals C. Now which one's C? Well, C is a hypotenuse, and it's always the longer side. But you can always look as well, it's always the angle that, or the side that's directly opposite of the 90 degree. So this right here is the hypotenuse, which is C. So here we're going to have 48 squared minus A squared, well that would just be the other leg that we already know, which is 20 squared. So B squared equals, now I don't know what 48 times 48 is. I do know that 20 times 20, because 2 times 2 is 4, and there's 2 zeros, but I do not know 48 times 48. So let's see here, 8 times 8, 4 times 8, 32, plus that, 38. And then do the same thing again. No, or not. 8 times 4, 32. 16, 19. 4, carry. 2304? What the? Okay, 2304. And of course we have to minus 400. So 1904. To get the B alone here, we'll square root both sides. The square root of 1904, which we can, I mean, I know I can divide that in half and I'll get a 2, and I can divide that in half again, which is a 4, so I know I can at least divide this by 4. I wonder if I can divide it by 8. I'm just going to try. 8 into 1904. 8 goes into 19 twice, which is 16, which is 3. Carry this down. 8 goes into 33. Nope. Yep. 24. Which is 6. Oh, look at that. It does go in 8. So this can break up to 8 and 238. And 238 can actually break up again to 119. Yeah. And this 8 can break up to 4 and 2, and that 4 can break up, so this actually breaks up to 2, 2, and 2. And 119 is definitely a prime number. 117 we could divide, but 119 we cannot. So I'm looking for pairs. So we got a pair there, a pair there. 2 times 2 is 4. And then left over is 119. And you could try dividing 119 by things, like you know it's not 2, 4, or 6, it's nothing positive, but you could have tried to go 3 into 119, which is 3 times 3 is 9, which is 2, which is 29, and 29, it can't go into 29. So 3 wouldn't work, and then 5 obviously wouldn't. 7, you could have tried 7. 7 goes into 11 once, which is 4, carry. Oh, maybe it does. Because that's a 9. The 7 does go, so that's a 17. Okay, so this would have broken down to a 7 times 17. I'm just going to verify that. So yeah, I thought it was prime. Now, I do know that 7 is prime. This does work out, but 7 is prime and 17 is prime, and so those aren't going to break down. So in the end, your leftovers are 7 and 17, which multiply to 119. So in the end, it doesn't actually matter. This answer is still correct. I thought 119. It looks like it's prime. Turns out it's not. That's very interesting. That's cool. Okay, so now we got to take a look at the next one here. And okay, now we're going to find leg A, apparently, whatever that is. So I will write over here a squared, because that's what we want to find. And then I always go c squared minus b squared. The c comes first. Now c is the higher number, which in this case would be the 36. But again, opposite of the 90 degree is right there. So this is the hypotenuse. That's going to be very important for the next unit. So this is the hypotenuse, which again is letter C. So a squared, well, we don't even know what a is, so we can't do that. But let's start that out by going a squared equals c, what is c, 36? Minus b, 24. Okay, so both of those I don't actually know off the top of my head. 36 times 36. Nor do I know what 24 times 24 is. So 6 times 6. 18, 19, 20, 21. 18, 10. 6, 9, 2, 1. 1296. Alright. And then 16, 9, 8, 4, 576. So 1296 minus 576. So the gap between there is 720 maybe? Yeah, 720. So then you can square root both sides. That will cancel. And so a squared is equal to plus or minus, but we're only going to do the plus. Square root of 720. That's an easier tree to make, because this will be, sorry, a 72 and a 10. And 72 is just 9 times 8. And a 10 is a 2 and a 5. Now 8 always breaks up to 2, 2, and 2. 2 times 2 times 2 is 8. Of course, I can carry this 2 and the 5 down. And 9 breaks up to 3 and 3. Now, what do I have for pairs here? Pair of 3s, pair of 2s. I want another pair of 2s. Okay. So 3 times 2 times 2. Well, 2 times 2 times 2 is 4. 4 times 3 is 12. So there it is, 12. And the leftover is a 5. Actually, I think I did this. Okay, so there you have it. Maybe learned a few things. Definitely learned that 117 and 119 are both not prime numbers, which is pretty good. And I also learned that apparently I can't draw a rectangle without the computer glitching out. So I'm just going to zoom out here in case you need to take a look at this. And I think that's it for this chapter. Yeah, I think it is, yeah.